Hey everybody, thank you for clicking on this video. I really appreciate it. If you haven't subscribed, please consider doing so. So what I normally do on this channel is I take old electronic projects from old electronic magazines, I build them, and I bring them to life. That's what I do. So I'm hoping that interests you, and if it doesn't, try to hang in there anyway, because I am pretty much here to entertain more than to educate. And in fact, I learn more from the comments that I get from all the people. And I'm really grateful for it too, by the way. I never really had any help or assistance, doing electronic projects. And when I was younger, I didn't have the money. So anyway, I'm learning as I go, and thank you for all your help. I really, really appreciate it. Again, I'm not a genius. I'm just here to have fun. So we're going back to everyday electronics, and it comes from the October 1986 edition. So yeah, that's 39 years ago. And what we're going to build is an amplifier, a 10-watt RMS, supposedly. We're going to find out later, amplifier. And I'm showing you the author's version right now from the magazine, and I'm showing you now the inside of their version. Hopefully mine gets to that point too. And another picture, which I'm not too sure is what it is. Now, we're going to be using the TDA 2004. That's the chip we're going to be using. So I know it's got a bad reputation for car stereo amplifier chips, but you know what? Let's build it, see how it sounds. And from the description of what I read, it sounds like there's a couple of neat little things before it hits the amplifier that can maybe make it sound better. Anyway, let me just put you on pause right now, and we'll come back with the block diagram. Okay, so I'm showing you the block diagram from the magazine. If you look at the left-hand side, we've got the flat input box. The 1 mega ohm input will be for things like line level, right? My function generator, anywhere from 100 millivolts to, let's say, 1 volt. That is what's going to be for the 1 mega ohm input. And the 47K input, that'll be for things like microphones, guitars, things that are kind of low to medium in level. And then if you look at the box below that, that's the RIAA. Equalized input, so that will be our record player. Our record player will go into that. And the outputs from those two inputs are mixed together. So you could actually combine the two if you like. But anyway, it's going to go into a mixer and soft limiter. So I read a little bit about the soft limiter. Maybe I can talk about that a little bit better on the schematic portion. And I'll do my best. I'll just basically read it from the magazine. Anyway, that output will then go to our power amplifier, and that's the TDA 2004 chip. And this chip is a dual channel chip. However, we're going to use the other amplifier, and we're going to bridge them. It's called a bridge amplifier. And that'll go to one speaker, as you can see. And we also have our power supply essentially at the bottom. So we've got a transformer and a regulator. So that's the high level. Let's move on to the schematic. All right, so I'm showing you the schematic, and there, if you look at the top left-hand corner, you'll see those are two inputs, right, for guitar and then line level. And then there's also another circuit at the very bottom left, and that's for the record player, right? So if you go back to the top, you'll see that the output of that first op amp goes into a potentiometer. But if you look at the output of the bottom record player amplifier, preamplifier, goes also into IC3, the non-inverting, right? And that's where our mixer is. And we've got a master volume on the output of that IC3. But if you look at C8, so the feedback portion of IC3, you've got a capacitor and a resistor there, and that's set up for the low to high levels. And there's some diodes at the very top. And what that'll do is at the higher levels, that'll start to conduct. And that's what they are talking about when they talk about the soft characteristics of the block diagram. So they call it a soft limiter. And that's what that's all about. Anyway, the output of that then goes into the TDA 2004. And what we're doing is we're using both amplifiers. So that chip is has two outputs actually, so left and right. But in this example, what we're doing is we're bridging the second amplifier to the first. And the way they describe it in the article is the feedback network of resistors are 17, 18, 19, 20. And capacitor C 14 and 16 is arranged so that the output of the lower amplifier is the exact opposite to that of the upper amplifier. The loudspeaker is connected between the two outputs so that the maximum voltage swing across it is twice that of each signal stage. So that's what's going to give us our power. And I guess that's a neat design. We'll see how it works. Anyway, and then of course we've got the power supply at the bottom right-hand corner. So let's get into the actual build. So I'll show you what I've got so far. Okay, so good news. I had all of the parts in my parts bins, so that's great. So there's a lot of parts in here, only because I think I might build 2 boards for the main amplifier, right? And I think I'll even make 2 of the phonograph amplifier sections, right? The preamp. Because if you remember in the schematic, what they did is they tied both outputs of the record player into one input. I'm actually going to separate them. So I think I'm going to do that. I'm going to try to build 2 preamps and then 2 of the boards. Wish me luck. I think this project just got a lot bigger really fast. Okay, anyway, what I really want to show you is the boards. As you can see, I've got a whole bunch of them. So these boards measure 8.5. No, it's actually 8 inches by 4.5. So 4.5 that way. They're really nice looking boards. The back, they have some sort of a logo on there. Can't really make it out, but they're really nice. And I only got them for $1 a piece. Yes, you heard me. They look to be about 1.2 millimeter thick too. So I'll be able to cut them with my shears, which is a blessing. I'd rather do that than use a jigsaw. So I made out like a bandit. I bought 150 of them. You heard me, 150 of these boards. If you're interested in the boards, they were on Marketplace, but they're no longer on Marketplace. But if you're in the GTA, Toronto, Hamilton, Mississauga area. He lives in Mississauga. Obviously, I'm not going to give you the address right now on this video, but I can give you his phone number if you send me an email. And if you go to my main channel page, there's, I think, more, describes what the channel is all about. And I think my email is in there. So just email me. I'll give you the phone number and you can go there. He's in Mississauga, so I'll let you know that. I might have said that already. Anyway, he's in Mississauga, so if you're in that area and you want to buy some blank PCBs, well, this is the guy. It's incredible. Yeah, so I think for this time, or this video, I'm not going to show you the process, of doing the toner transfer method, etc., etc. I'll just do all that, and then I'll bring you back in once I got the boards complete. Okay, so the boards are done and they are tinned, except for that one that you're looking second to the right or left. Probably could have used some more tinning solution, but whatever. The boards overall turned out good. I probably should have spent some more time, though, on the editing or cleaning up of the board traces from the magazine. So a lot of times, almost every time, in fact, when I cut it from the magazine and paste it into a photo editor, it doesn't look great. So I use some of the filters to change the contrast and also to sharpen the traces. So I am using the GIMP program. So that helps a lot. But there's still, sometimes you have to thicken the traces, but in this case, the traces were already pretty thick. But they were, the traces are close to other traces, so you have to kind of clean them up. I should have spent a little bit more time on it. And another little problem I had this time around is when I pulled off the blue paper after I sent it through the laminator, some of the blue stuff kind of didn't come off, or came off, I guess is the answer. And you can see that with that spot there. Luckily, it's not a big thing. But anyway, the boards overall are good. And not only that, but I am using the boards that I bought just recently. So I bought one board for $1, and they're excellent boards. And in fact, when you run your fingernail through the traces, you could feel the thickness of the copper. So I'm really, really, really excited about these boards. So anyway, let's move on with the build, and I'll do a stop time lapse kind of thing, and I'll bring you back in after that. Okay, so I'm making real good progress on the actual circuit boards themselves. However, I really need to size out a case, right? And I'm kind of fed up with paying a lot of money at the store. Like, I think the box that I'm going to make, and that's what this part of the video is probably around $58, I think, because I need a fairly large one. And yes, I remember it was $58 for an aluminum case. So that's crazy. So I decided a while back, and I did another video where I built my own case. I think it was a guitar practice amp. In any event, I'm in need of a case now for this project. And because I'm using, I'm building everything twice because I want a left and a right as opposed to just a mono, I am going to build a case. And so I've kind of got it all sized out, as you can see here. So I went outside, and I bought a whole bunch of sheet of aluminum from this one metal store, I guess you can call them that. And they had just what I needed. In fact, I bought some really thick aluminum, which was the last project. But I did buy one sheet of thinner aluminum. So I think this is the right size. It'll be much easier to bend on the brake press. And this is where my fume hood goes. Normally it just exits the window, but it's portable. I could just lift it off. It's very light and start to do some aluminum work. So I've got it sized out. I cut it outside, and as the red lines, of course, are where the folds are going to be. So I'm not going to show you the whole process. I'll just get it done, and then I'll bring you back in. Okay, so I've got the sides bent, as you can see. And what I have to do now is make 2 bends inside. So how do I do that? Well, I do have that long bar, but it's too long. Obviously, it would the smaller bends would be in the way. So what I'm going to do is I'm just going to use an old piece of metal that I had lying around, and then just bend that up, and then I'll do the other end too. All right, bring you back in when it's done. Okay, so it looks okay. So this is the side here. So this will be the front. So yeah, I've got a lot of stuff going on in the front, but plenty of room. And as you can see, looks pretty good. I mean, it's not, Hammond manufacturing quality, but it'll do. All right, so, sorry, this is the bottom. What am I talking about? That's the bottom. That's the way it's going to go. And so what I'm going to do is just cut a piece of aluminum outside and just bring it over like that. So this way the front is nice and smooth here. I used to make the cases where, well, I only made one, where I'd have like this. It would be like that. In fact, it would probably be like that. That's the way it would be. It's not so bad having these smaller edges in the front. That's how a lot of the Hammond cases are made now, actually. But somebody had suggested earlier that, hey, why don't you go like this? And And I think that's the way to go. Anyway, I'm talking too long. Let me get the other piece and get going. Okay, as you can see, I screwed up on the top piece. Yeah, just, I don't know. I measured twice and I cut once, so I don't know. But anyway, you know what? There was another problem. Anyway, I forgot to leave overhang. So, you know, it's basically the same. This part should overhang the top, and it isn't. I just made it square, so silly me. I thought about maybe putting, no, again, I want that overhang, so I'll have to buy some more metal. I was planning on going tomorrow anyway, and I'll get some more of the sheet metal, and I'll do it properly this time. However, I do have the bottom portion, so I'm happy with that. And then at least I can start to put some of the components in, or the boards in, right? Anyway, thanks for hanging in, and let's get on with the boards. Okay, so I'm showing you the preamp board. It's done. I've got all the controls connected to it. And I'm going to test this separate from the actual power amp board. First, I'll make sure that I've got all the voltages on the pins on the ICs. And then I'll put the ICs in, and then I'll put a small signal into it and see what I get on the output. All right, so this is the power board, so the power amplifier board. And I'll test this one separately too. I'll just apply 15 volts to it, put a small signal in, and see what I get out. So yeah, let's get at it and to it at it. All right, so I've got some good news in that the circuit is working. So this is the preamplifier, and I have another one. I haven't tried it out yet, but this one works, so that's a good sign. So that is our. So right now I've got the input signal going into the auxiliary input. So this is the input that I mentioned earlier. That, you know, maybe 100 millivolts to 1 volt. That's what they were saying in the article. So that's not the phono input. This is just an auxiliary. And that's the master volume. And then that's the, I guess, auxiliary volume. I guess there is a situation where you could have, you know, like a phonograph input and also an auxiliary input. In any event, this is just for the auxiliary input here. And what I've got is I'm using my function generator here. So that's the one I built a long time ago. Like, I don't even remember building it. It's like 20, 30 years ago. But it works really good. Now, I just recently built this one here. And I'm not using it right now, only because it's got just a slight blip in the sine wave. So I want to, what I'm planning on doing with this one, by the way, is I want to get a genuine XR2206 to see if that goes away. But if I'm going to be doing some finer measurements here on this project, I want to make sure I've got a clean sine wave. So in any event, let me just push you up to the scope here. So hopefully you can see that. And I guess the first thing that we notice is it's 180 degrees out of phase. And let me just adjust the auxiliary volume and the max. So I am at max already. So let me just change the scales here. There we go. Now you'll see when it's maxed out, the waveform is different than the input. So we are losing, I don't know what to say, fidelity. I'm not too sure. There's no tone controls on this circuit. So there's nothing like that on it. Now, if I reduce the auxiliary input, or sorry, a potentiometer, it does shape up to be much better. So I'll just go back down a scale. So it looks a lot better. It's only when I max out that it rounds up at the top. And this is master. And this is the auxiliary input. So the first input. And what am I getting? So I've got everything at max right now. Oh, that wasn't max. That's max. All right, so everything's at max. So what do I have? I've got 1, 2, 3 divisions, and I'm on the 0.1 scale. So that's 300 millivolts. So the gain from 100, oh, by the way, I should have mentioned the input is set to 100 millivolts, and the output is now 300 millivolts. And I'll just back it off a little bit. So there is definitely some gain on the preamplifier. All right, so let me just try to test out the phono stage. Okay, before we test out the phono stage, I forgot to just go through the frequency ranges, right? So I'll just change to mid-range. And if you look, we're at 3 on the output, which is the bottom. It stays the same. So what we are, I don't have a readout on this function generator, but I did write it down. And right now I'm at 1.44 kilohertz. So, but if you look at the actual voltage level, it's pretty much the same as it was on the lower. Now that's the high, so that definitely did go down a little bit, not much. What do I got? 1, 2, yeah, actually, you know what? It's the same. Okay, I thought it was going to be a little bit different. So we have linearity, at least anyway. And this is 15 kilohertz. So it's 15 kilohertz, so that's the output. So not bad. It's a little deformed if I go up a little bit. But it's pretty good. So we've got a good frequency range. All right, so let me just go to the phono input, see what we get there. Okay, so now I've got the signal generator going into the phono input. And my function generator will only go down to the level you're seeing now. So it's about 20, yeah, it's about 20 millivolts. Yeah, what can I say? I don't want to get too much into the testing, only because when I put it in the case, I'll probably do a lot more testing. So just quickly show you that it works. Again, I've got that weirdness if I go above a certain threshold. And I'll just go through the ranges. So, by the way, we've probably got about 1, 2, 3, 4. Yeah, about 4 divisions and 50 millivolts. So that's 200 millivolts. So 20 millivolts to 200 millivolts. Now I'm on the low frequency. I'm only at 150 hertz. Let me just bump that up, and you can see it goes down. And we're probably at 1, 2, 3, just a little over 3 times 20, or sorry, 3 times, 20 millivolts, 60 volts. So we do go down, and this is the high frequency. That's 15 kilohertz. And it's practically nothing. In fact, it's about the same as the input. Anyway, I don't want to get too much into the testing. I just want to show that it works. Let me just hook up the power amplifier really quickly. Okay, so I'm testing the amplifiers right now. So I'm not using the preamp board. I'm just inputting a signal to it. And I do get sound. I do get my tone out. But every time I hook it up to a scope, it just motorboats, right? So, but there's a bigger problem before that. And it has to do with the quiescent current. So let me just demonstrate. I don't have any power going to right now. Nothing is connected to it. No input, no speaker, no nothing. And just because I wanted to, on the right-hand side, I separated the voltage regulator just in case, there was some sort of a ground loop or something like that with the TDA chip. But the same result. So the quiescent current is too high. So let me just push you over to my homemade power supply. And I'll turn the power on. And then right now I'm reading current. So you can see I'm drawing about 0.7 amps. And that is a lot. According to Google, the quiescent current should be about 65 to 120 milliamps. So I've got a problem. Not too sure where. Both are doing it at the same time. So I don't know. Maybe bad design. I'm not too sure. Anyway, let me look further into that and I'll get back to you. Okay, I found the problem. I had the wrong resistors. They should have been 2 1 ohm resistors. I put 2 1K resistors. Silly me. It's fixed now. Anyway, the quiescent current, as you can see now, is more reasonable. So that looks to be about 100 milliamps right now. So that's just in line, quiescent current. So let me increase the signal to its max, which is right about there. And we're drawing almost 1 amp. In fact, I'm clipping right now. So let me just back off a little bit. Probably about there. Yeah, so it's about 0.9 of an amp. And there's our signal. So it looks really, really good. So let me just increase the input And you can see it's clipping now. So it looks like we've got about 13 volts peak to peak. Anyway, don't want to get into detailed testing. I'll do that later when I put everything in a case, but everything is working now. So that's what I'm going to do right now, is put all the boards in the case and then test it out one more time. Okay, so I think this is going to be the rough layout of how I'm going to put the boards in. And yeah, so that's it. Anyway, I'll get on it. Okay, so as you can see, it is done and it works. I'm really happy. Now, the case is fairly large. It's probably, I think it was 36 centimeters wide. So that's a lot of real estate. That's over a foot, right? But you know what? I made the case. I'm glad I did. And I have lots and lots of room here. I think I probably could have condensed it into a smaller case, but c'est la vie. It is what it is, as they say. So anyway, we've got our left and right channels. So the first board is our preamp, and there's our TDA 2004. Same thing over here. So yeah, I made 2 channels. I know it's a bit awkward. I get it. You know, having the speaker outs in the front, but you know what? It's a magazine project, right? What the heck? Anyway, so yeah, what can I say? There's oh, I had this line filter in my AC cords bin, so I scrounged that for something. So I just figure, what the hell, I'll use it. And yeah, so we got an AC in and a fuse and a big old transformer. And there's the basis of our half or full wave rectifier power supply. And then of course that goes into the 2 boards, and from there goes into the top board. And we've got some AC running here. I elevated the AC lines just, you know, to be safe. So I've got them high up. Anyway, let's just do some testing. Now, I'm going to be really quick because I know this video is getting long. So we'll go through the paces and I'll bring you back in. Okay, so I want to do a power test, but I'm going to need your help. So right now I've got it at maximum before it clips, and I'm reading about 13 volts on my scope. So when I put that in the audio power output calculator on the internet, it works out to about 2.5 watts. I find that unbelievable. I had a speaker hooked up to this thing, and I had to put earplugs in, and I had it at full power, and it was still very loud. So I know it's well beyond 2.5 watts, definitely 10. And what I wanted to do, in fact I did, is the reason I've got it at a low frequency is I've got my AC voltmeter on, right? So we got 8.5 volts. And when I put that RMS, because this is an RMS, true RMS, it gives me about 9 watts. And that's what I expect with the chip, the TDA 20, I don't even know what it is anymore, 2004. So can somebody help me out? Why am I not getting the right reading on my scope? I figured it should be a lot more than that. Maybe I just have bad luck with scopes. This is the second one. My other Tektronix, kind of the horizontal went, so I didn't bother looking into it. But I kind of like the scope. It's the 465. I love the way it displays, and it's a great scope, but I just don't understand the power. And I know I had this problem last time too when I had an audio amp. Anyway, if anybody has any suggestions, let me know. But I certainly know this is at the maximum. Anyway, let's do some more testing. Okay, so let's go through the ranges. Let's kind of do a manual sweep. So I'm on really low frequency right now. Switch it to the medium, and then that's the high. So if you look at the actual voltages, it does increase when I go to medium range, which right now, by the way, is 1.2K. So we do get more. It's a bit clipped, so I might have to back off a little bit. But we have a little bit more gain, but still nowhere near the 10 watts, what I should be reading or calculating. Anyway, so there's the high range, and it still looks pretty good. And we're at 12.8 kilohertz right now. So pretty good. I really can't go any higher. Oh, yeah, I can go a little higher. No, that's it. That's the max I could do. So 14.75 kilohertz. Okay, so I don't know if you remember, but this is the True RMS audio meter that I made a while back. So I've got it maxed out right now. Well, just before peak or clipping. And I'm getting about 8.5 volts RMS, right? So I'm at about 1 kilohertz at this point. And that kind of matches up to what I had on the meter. Yes, I know the meter was really low frequency, but this is a higher frequency. So it's looking like the higher value or not, or the value on my scope is not correct. But anyway, let's see if we can do another test. Okay, so I can't do any more tests. I am having some troubles taking a THD reading. We'll get into it. This video is getting long enough anyway, so it's probably time to end it. And let me just let you hear the music. So for YouTube, if you're listening, this is actually audio from your library. It's Taking in the Changes by Evert Almond. All right, so as you can hear, it sounds wonderful. And I've got it really low at this point. It does go very loud. Anyway, let's end the video here. So thank you very much for watching the video. I know it's a long one. I appreciate your support. If you haven't already subscribed, please do and like. And look out for the next video. Thanks for watching. Bye for now.